Hey guys, welcome back to my YouTube channel. My beautiful name is Nyambora Kibe. Thank you for your continued support. For the returning subscribers, Manzi, for the new subscribers or the new members in this channel, please take 5 seconds of your time, please, to subscribe to my YouTube channel, to like my video, to comment this video, and I will appreciate Manze like much appreciation. You just don't know how much. Like, I really need that like, that comment, that subscriber, that +1 subscriber. It gives me morale to keep on doing whatever I am doing. Today we're going to learn about one very interesting topic. It's in ordinary differential equations too. And the topic we're gonna learn is Wrongskian. Yes, Wrongskian. It's a very interesting topic for me. I hope you find it as interesting as I find it myself. Wrongskian. And the cheapest definition I can give on Wrongskian, I can say it's the determinant, and in this determinant, the first row contains the end functions of x, and the second row, or the following rows, the rows that follows, are the successive derivatives of the same functions with respect to x. That's the easiest or the simplest definition that I can give to Wrongskian. Probably we can do an example so that we can understand further. Example 1. We can see that we find the Wrongskian. Find the Wrongskian of two functions, i.e. the first function of x is x squared, and the second function of x is x cubed. How do we tackle this, guys? So on the solution part, as you have said, that Wrongskian is the determinant, so it's the determinant, and the first row is the end functions of x. So our first row is x squared and x cubed. Determinant is written like this, or is represented like this. Now, but the derivatives of these functions with respect to x. The first derivative of x squared in respect to x is 2x. The first derivative of x cubed with respect to x is 3x squared. So we find the determinant of this now. So we say that the Wrongskian therefore will be the determinant is this times this minus this times this. So it will be 3x squared times x squared minus 2x times x cubed. So the Wrongskian will be 3x power 4 minus 2x power 4. And our Wrongskian will be x power 4. It is as easy as that. That is how we simplify the Wrongskian of a function, or the Wrongskian of two or more functions. We can have another example. We can have example 2. Example 2. And in our example 2, we can find the Wrongskian of e power x, e power negative x, and e power 2x. The Wrongskian. So we say the Wrongskian will be given by the determinant of e power x, e power negative x, e 2x. That's the first row. The successive rows will be the successive derivatives of these functions, ex, e power negative x, e power 2x, with respect to x. So what will be our first derivative of this with respect to x? This will be just e power x. The first derivative of e power negative x with respect to x will be negative e power negative x. The first derivative of this one will be 2e power 2x. We're not yet done. What will be the second derivative of e power x? It will still be e power x. The second derivative of e power negative x will be now e power x, and the second derivative of x, e power 2x, will be 4 e power 2x. Yes. So we find the determinants now of this. So this is a 3 by 3 matrix. So how do we find the determinant of a 3 by 3 matrix? We learned this in calculus 1, I think. Just to remind you, this is how we look for the determinant of a 3 by 3 matrix. For the first one, let me use a different pen so that we can understand. So for this one, we start by writing this e power x, then you multiply it by, you cross this first line and this first line. That is for the first one. So we will be left with this 2 by 2 matrix. So it will be this times this minus this times this. So it will be 4e power 2x times e power negative x minus e power x times 2e power 2x. Then we go to the second one and to look for this determinant. The first one will be plus, the second one minus, so as you continue it's minus. The next one will be plus. Yes, like that. So minus the second one here is e power negative x. So we multiply this by, we come and hide this one, this line that has that function, and the first line above there. So we'll be left with this 2 by 2 matrix. So 4 times this 4e power negative power 2x times this minus this times this. So it will be 4e power 2x times e power x minus this times this minus e power x times 2e power 2x, then plus our last one here is e power 2x, so we multiply that by the last one. We cancel this, use a blue pen this time around, that, and we cancel that. This will land in caps plus 1, so we multiply that by this times this minus this times this, so e power x times e power x minus e power x times negative e raised to power negative x. So what do we get when we simplify this? We get, here we will get e power x multiplied by negative 6e power x, isn't it? Then minus e power negative x. If we simplify this, we will get 2e power 3x. Then the last one will be plus. If we simplify this, we get 2e power 2x. So if we work out all these, this will be negative 6 e power 2x. That will be our answer. It's not a long sum. It's just as easy as that, finding the determinant of the functions of the n function of x and the derivatives with respect to x. Probably we can look at a final example on that, so that we can simplify, so that I can simplify to the best way I can. So probably we can have a final example 3. And here we will find the Wrongskian of x squared and x cubed, so that I can show you how to do another 3 by 3 matrix. To find the determinant of a 3 by 3 matrix. So in the solution part, we have said the first row we will write the n functions of x which we are given. So it's x squared, and x power 3. The first derivative of x with respect to x in this is 1. The first one here is 2x, and the first one here is 3x power 2. The second one here becomes 0. The second one here becomes 2, and the second one here becomes 6x. So we'll find the determinant of this, which will give us the Wrongskian of these functions. So this is another 3 by 3 matrix. So just like the previous example, we will start from x. We cross this and we cross this, so we are left with this 2 by 2 matrix, which will be x 6x times 2x minus 2 times 3x squared. Then the other one will be negative x squared we multiply that by, you cancel this in the line, the column where the x squares lie, so that we are left with another 2 by 2 matrix. So it will be 6x times 1, that is 6x, minus 0, because 0 times 3x squared is 0. And the last one will be x cubed. We cross this one and this one, close the row and the column where that specific function lies, so that we are left with a 2 by 2 matrix. So it will be 2 times 1, that is 2, minus 0 times 2x, that is 0. So it will be just that. So we will be left with x. If we work out that, multiplied by 6x squared minus 6x cubed, yes, this times this, plus 2x cubed, this times this. I hope you're right. So if we multiply this and this, we will have 6x cubed again, minus 6x cubed plus 2x cubed. This and this cancels because it will add up to 0. So our final answer will be 2x cubed. That is how we find the Wrongskian. Thank you so much for watching my video. I hope you are helped by that video. I hope this Wrongskian thing will stick into all of our minds. See you in my next video. Ciao.